Now that we've applied this tentacle sim to the creatures, we need to rerun our disintegration effect. So I'm just going to copy this disintegration geometry object from the previous week. I'll paste a copy down here in our week 4 section and call this disintegration with tentacle sim, and then dive inside here. And as we're rerunning this disintegration here, I'm also going to increase the resolution of the effect. So if we go up to the top of this network and display the vellum constraints grain, and then zoom in on that, if you middle mouse on vellum constraints grain, you can see this is using 520,000 points, which may sound like a lot, but oftentimes when doing particle effects or grain sims, we want particle counts in the millions. So I'd like to try a resolution closer to 2 million or so grains. So if you select that and go to the grain size here, let's try reducing this to 0.15. And very small differences in the grain size can have a drastic effect on the number of generated grains. So if we check it now, we now have 1.2 million grains, and I'll try going a little bit higher res. It looks like 0.13 for the grain size is giving me just under 2 million points. And that sounds pretty good, so let's stick with that for now. And I'm not going to change anything about the grain setup at this point. If you go down to the solver for our activation growth, that's the last step before we do the point deform to apply the animation. Now if we display the point deform, that's currently driven by the old animation with the basic procedural noise on those tentacles, and to update this with the tentacle sim version, if you go to the object merge, that's pulling in the creature from creature flying basic and change it from creature flying basic to creature flying simulated. So now this is driven by the actual tentacle sim. And with this increased number of grains, the intermediary cache for the relaxed grains is going to be extra important. The velocity calculation and then relaxation can be a very slow process with high point counts, so we certainly don't want this to be recalculated on every frame as we're running the actual sim. So for this relaxed grains cache, I'm just going to update the path here so it's different from our previous version of the setup. I'll change the file path to relaxed grains _ high res. I'll put that in the file name as well. And now let's recache these relaxed grains. And now with almost 2 million grain particles, I'm actually finding this point relax process to be far too slow. This seemed to be taking more than 2 minutes per frame to cache out just this relax process. So we could try bypassing the relax and seeing if the simulation behaves nicely or if it really needs that relax. Or we could also try just turning down the number of relax iterations. So I'm going to try that. I'll try doing 5 max iterations instead of 10. And we can check how long this is taking before we do our cache to see if it seems acceptable. So the trail's reasonably fast. And now let's check the relax. I'm going to open up my performance monitor, hit record, and then display that relax. And even with the max iterations turned down, this is fairly slow. It's still taking 1 minute and 25 seconds. So now let's turn this down even more. I'll just do 3 iterations. And now at 3 iterations, that's quite a bit faster. I'm going to clear out my performance monitor again and try one more test with 4. And with 4 iterations, this is taking about 1 minute to do that relax, which is a little bit slow, but that's fine. I'm going to just clear out this performance monitor and run that cache with those 4 iterations. So now our relaxed grains cache is all finished, and that did take a while. It took a little bit over an hour, so certainly feel free to run your simulation lower res, or as I mentioned, you can try just running the sim without the relax and see if it really needs it, if you don't want to spend all that time on the intermediate cache right now. But in any case, we have our relaxed grains available for us now. So now let's go down to our simulation cache after the DOPNet. I'll rename this Cache Disintegration Sim, and I'm going to change the file path. Instead of disintegrate basic, this will be disintegrate high res. And now let's cache out the simulation. And now reviewing our updated sim, everything is looking pretty good. It looks like the sim is behaving nicely. We're not seeing any problematic instability or glitches in the sim, so I'm pretty happy with this. Right now, we are seeing perhaps a little bit of stepping along the tentacles. You can see that the tentacles are sort of breaking apart in chunks here, which is likely due to the stepping frame to frame of our grain activation. And if you want to remove some of the stepping of these tentacles being activated, you could potentially increase the substeps of your simulation, but that means that you will also need to increase the substeps of your intermediary cache here for the relaxed grains, and increase the substeps on your solver activation growth as well. Our SOP solver for the activation growth has the same type of substep controls as our DOPNet does for the sim itself. However, if you do increase the number of substeps, then you're going to need to change the frame variable on your relaxed grains cache here. So if we take a look at the cache for those relaxed grains, and then open up our timeline settings to turn off the integer frame values here. This will allow us to set subframes in our timeline. And we're at 119 right now, so I'll go to 119.5. So at frame 119 and a half here, if you look at the cache that this is pulling in, we can middle mouse click on this geometry file path here to see the actual resolved path after those variables are evaluated. And you can see that at frame 119.5, this is actually pulling in cache frame 120 because this $F3 is just an integer value here. So if you do want to cache out some substeps on your activation, then you're going to need to change this $F3 to $FF. And right now, changing that is breaking our cache because we don't have any cache frame at 119.5. But if we middle mouse click on geometry file again, you can see that now this is looking for a cache with the name of frame 119.5.bgo.sc. So in my case, I'm not trying to substep the activation or anything. I'm just going to leave this on $F3. But adding those substeps is something you can certainly experiment with if you'd like. And you do have other options as well for reducing the issues of chunked activation like we're seeing. We can also add some secondary simulations to this. So it could look quite nice if we add a dust sim layered in with all of our grain particles here. And that dust sim can help to fill in the gaps quite a bit, and layering up simulations like that can certainly help to avoid any apparent issues with any one simulation, because combining extra layers just makes things look more detailed and visually rich. And in some cases, we really want to avoid substepping artifacts, but in some cases like this, extra layers of sims can certainly help to avoid those little issues. And also, just on principle, I kind of don't mind the tentacles coming apart in little chunks like this. Let's turn our integer frame values back on for the timeline here. And if we jump to a later frame of the sim, one of the nice things about using grains for an effect like this is you do get a lot of chunking mixed in with all of the particles here. So because that's part of the look of the disintegration we're going for, I actually don't really mind some chunking in the way that these tentacles are coming apart here, because to some degree that makes sense with the overall look of how this is disintegrating. Now we're currently simulating about 1.8 million grain particles, and my simulation took just slightly over an hour on my machine. And for a high-res sim, an hour is really not too bad, so you could certainly go even higher resolution with these grains here. You could perhaps try adding another million grains on top of what we already have, and as long as your intermediate cache time and your sim time remains reasonable, that extra layer of detail and fidelity with that many more grains could potentially look quite nice. And as you're deciding how far to push the resolution on your final simulations, it's important to do some renders as well, because what we see in the viewport here is really kind of just a preview of what it's finally going to look like. So it's pretty important to see this actually rendered with the actual lighting and material and motion blur and camera moves and everything else, because the look of those final renders can certainly influence how far you need to push the fidelity of the simulation. And speaking of renders, we have to make sure that we also point our render objects to our updated simulation here. So going back to the object context, and then going to our render disintegration points here. Instead of pointing this to object, disintegration, render disintegrate points, we'll point this to disintegration underscore with tentacle sim. Now that gives us our new disintegration sim there. And we also need to change the disintegrating creature as well. This disintegrating creature render object here is the one that's eroding as the disintegration grains are activating. In this one, we're also going to need to point to disintegration with tentacle sim. And right now, this eroding creature here doesn't represent our updated simulation. So let's jump over to that disintegrating creature here. And we don't actually need to change anything to update this. We're already bringing in the correct creature with that tentacle simulation. And we already have this erosion set up based on that distance from geometry. So all we need to do is go to our creature erode cache. And I'm going to add high res to the name of this cache as well to differentiate it from the old version. And now we can cache out this new creature erosion as well. And now that the cache for the creature erosion is finished, we can go ahead and display the merge where it's being combined with the grain points. And right now, a bunch of the attributes are being removed from the grain points here. If you look at that attribute delete, it's removing our sprite attributes in particular, which can be much heavier to display in the viewport, but they can make things look a bit nicer for display preview purposes. So instead of displaying this with those attributes cleaned up, I'm going to connect this color to the blast stop that's deleting our inactive grain particles. And this looks a little bit nicer for our flipbook preview. And let's go to the camera for our disintegration shot. And I'm going to turn on show all objects so that we can see everything else in context. I'm going to pin my viewport and the disintegration with tentacle sim. And just to make everything look nice and consistent for our flipbook, back on creature flying simulated, I'm going to dive inside there. And instead of displaying out deforming creatures, we'll turn on this version with the darker color display. And then run a new flipbook to see what everything looks like. And flipbooking everything all together, this is looking pretty cool. We are seeing one issue here with the creature that's eroding starting to reappear as the animation pulls away from our activated grain particles. And we can fix this fairly easily if we just go back to our disintegration with tentacles. And then on this creature erosion cache, we can stop caching this out after the final frame of the creature activation. And to keep things nice and procedural, we can link this to the cache for the relaxed grains. So if you select your relaxed grains cache, we can right-click on the end frame here and copy that parameter. And then on our creature erosion, we can paste a relative reference in for the end frame of that cache. In this case, I don't want to relative reference the first frame because our activation cache is only starting at the frame the activation actually begins, and in our case, we want the creature erosion to be cached for the earlier frames as well, because we need this cache available before the creature actually disintegrates. So we're going from frame 1 on the creature erosion up through the last frame of activation, which in my case is 160. And then we're going to need to time clamp this to the end frame as well. So drop in a time shift, set the clamp to last, and we'll paste that relative reference in there as well. So for all the frames after frame 160, it's still going to be grabbing frame 160 of our cache, which in this case is totally fine because by frame 160, the creature is totally eroded, and that's just bringing in an empty cache. And actually, it looks like at frame 160, this cache is not quite empty. Looks like we have a few stray polygons left here. If we zoom in on just those polygons, I'm not seeing much, but I am seeing this little piece over here. You can turn on point display as well to see what sort of tiny little polygons or disconnected points there may be. So yeah, we do have just a few stray points and polys that aren't getting deleted by our erosion. And to fix this and make sure that we don't have any of these stray points or polys, we can go to our creature erode cache, and on the load from file tab, set the missing frame behavior to no geometry instead of report error. And right now we're still seeing these points and polys after frame 160, and that's for two reasons. First of all, we have this time clamp here that's clamping our input to the last frame of 160, so it's just pulling cache frame 160 on all the later frames, so we don't need that time shift anymore. And because I already have an existing cache for the entire frame range here, I'm going to go ahead and delete all the cache frames after 160. So just selecting 161 all the way to 240 and deleting those cache frames. And I'll hit reload geometry on our creature erode cache. Now this is going to ensure that we're getting no geometry coming in for any frames after 160. So now let's go down and display the merge with the eroded creature and our grain simulation here, and go back to our disintegration camera. Now if we check the end frame, that's all fine, and then if we check a frame before the sim, then you'll see we're not getting that eroded creature at all because our disintegration cache is throwing an error. So on the grain cache as well, we can flip the missing frame behavior here also. So instead of reporting an error, we can tell the grain cache to also give us no geometry on the frames where there's no cache. So with that option, it stops throwing this error that's messing up our merge downstream. So now this looks all good. And if we go to a frame in the middle of our sim here, just to make our viewport flipbook a little bit nicer, I'm going to change this grain color to more closely match the creatures. It looks like 0.6 brings that a whole lot closer, just to make our flipbook nicer. And of course, this is just our viewport preview. This isn't going to affect our actual rendering here. And now we can do a new flipbook to see what these latest updates look like. And now reviewing our new flipbook, everything is looking good. We're not seeing any of those issues that we had before with the creature erosion after the activation frame. And now you can go ahead and start running some test renders for this. And as I mentioned before, you can play around with different grain sizes and resolutions to see how it looks in render versus what your computer can handle, but you should end up with a rendered result that looks something like this.